So what we have here is a linear programming problem that has to do with manufacturing trucks and fire engines. It is a rather lengthy problem, so what I'd like you to do is pause the video, read all the information, and then come back and we'll hopefully be able to translate this into constraints and a function to maximize and solve the problem. All right, now that you've given it a read, you probably realize that there's a lot of constraints. The one thing to remember is that automatically we should write these down. And those are your non-negativity constraints. They might be covered elsewhere in the constraints anyway, but it never hurts to write those down. So taking it step by step, looking at the first line here, so the sheet metal. So for the sheet metal, we know that if each truck requires 2 hours and each fire engine requires 3 hours. So that means that 2x is the total time for the trucks, 3y is the total time for the fire engines. Add them together, we get the total time for both, and we know that together they cannot go above 24,000. So we say less than or equal to because we're not necessarily going to use up every single hour. We might have some left over. Who knows? All right, so truck assembly, looking at the next constraint. And I'm going to put that in orange here, truck assembly. So truck assembly says they can handle at most 6,600 trucks per week. Nothing to do with fire engines. So this constraint only has to do with X. So we're going to say X is less than or equal to 6,600. Simple as that. Okay. Next one only has to do with fire engines. Now we're told that we can handle at most 40 or 5,500 fire engines. So again, just color coding these so it's easier to read. I know that Y is less than or equal to 5,500. All right, moving on to the next one. So we have the painting department telling us, I can paint as many as 10,000 toys. Now that's between the two. So this means, if X is the number of trucks and Y is the number of engines, X plus Y is the total number of toys. And we're told it has to be less than or equal to 10,000. Oops, 10,000. And then last but certainly not least, the reason why we're here pretty much is for the profit. Now we are told that the profit is $9.50 per truck and $14 per engine. And we want to maximize this. So there's our objective function. And I'm going to call it Z just like we always do. You can call it P for profit if you want to. Z is just pretty much the standard. So we're off and running pretty much. So all of this information right here is your feasible region. Every solution that's possible must fall within all of those constraints. Now, I have already constructed the feasible region for us. This was done in Desmos. There it is. So as you notice, there are 1, 2, 3, 4, 5, 6 corner points to this. Okay? And to be completely honest, we do know that we don't have to check some of these. Okay? For example, 0, 0 in a maximization problem. I already know that I'm going to get 0. Okay? So that's done. 6,600 comma 0. Well, yeah, I know I'm going to get a bigger profit out of that because I increased X. So this is telling me that this is 950 times 6,600. And then plus 14 times 0. So the profit at that level is 62,700. So we'll see what happens after we plug in some more corner points. Now, looking here at 6,600, 3,400, I know that's going to be a bigger result because I'm making more stuff, right? I'm making 6,600 trucks, but I'm also now making more, which is going to give me more profit. So I'm just going to take the previous answer and add 3,400 times 14. And that's 110,300. So far that's the front runner. Okay, and actually that goes with this one. Okay, I'm not lining up too well here. So now let's check 3,750, 5,500. 9.50 times 3,750 plus 14 times 5,500. We we have a new front runner, 112,625. And 6,000, 4,000. 113,000. And if I look at these two, notice that I'm now keeping Y the same, but now I'm eliminating all the X's. That, of course, is going to mean less profit because I'm not making as many objects. So, I mean, and I'm making the same amount of fire engines, but I'm making fewer trucks. So that's going to definitely decrease my profit some. But again, formality, we'll just do it. That's 14 times 5,500. So from all of this analysis, what we notice is right there, right there is your maximum profit. Right there, $113,000. And when does that happen? When we make 6,000 trucks and 4,000 fire engines. Thank you so much for watching.